Okay, so Geoscience Australia, as Andy said and Anthony this morning, we're a science organisation. We have a lot of scientists, some who code well, some who code badly, and I can say that because I'm a scientist who used to code badly. I code well now. And we have a lot of IT staff and supporting staff at GA. And so what do we do at GA? We have a lot of data that comes in, and there's a lot of big range of data. There's a lot of different sorts of things that we have. We have sentinel hotspots and hazards modelling, such as bushfires and tsunamis and earthquakes and all that sort of thing. We do a lot of geological things, of course, a lot of maps. So there's maps everywhere at GA. We also do a lot of water studies like groundwater, rivers and lakes, and mapping those out as well, and marine studies, so mapping the seabed floor. And a lot of that is also underpinned by GPS. So we have GNSS processing, which forms the GPS stuff at GA. So our cloud journey so far. We were on-premise for a lot of stuff, and a few years ago we started moving towards using cloud services. In AWS, we released a digital science strategy that pushed this move towards the cloud. And there was a few reasons for that. That like on-prem, where it had limited scalability, it was very vanilla what we could use, and we had specialised teams in IT who looked after these systems. In moving to the cloud, we have a lot more customization available on what we do, and we have a lot of quick time to production, which was really, really important. So Andy was saying we're the cloud enablement team with Tom and James over here, and the sort of things we do is we like to support the scientists, the developers, and various teams within the agency. So GA has 3 science divisions, an ICT division and a HR division. And so within those science divisions, there's also a lot of developers who form MDTs, as well as, multidisciplinary teams, as well as individual developers. And they're working on getting these applications to the cloud services. And so we support those developers and those MDTs in providing information. But it's important to note that this is a two-way street, because those MDTs give us information back as well. There's a lot of collaboration around that. We give guidelines on cloud governance and look at example architectures and patterns across the agency when deploying infrastructure and systems on AWS. So we've moved to the cloud, everything's great, right? Well, there's always challenges, and some of the ones that we've come across in the huge uptake of AWS services across the agency, some of the best practices haven't always caught up with some of the things that have gone out. And so we might find in some places that production systems are on single EC2 instances, which is not so good. Single people have created this infrastructure and the servers that are running and installed everything, but haven't kept any notes or documentations, or their special Snowflake applications. And this image here is one I like to use in one of my science presentations on provenance. So I used to work a lot on provenance, which is the capturing of how data, workflows, applications, people, machines went into creating an end product. So you're able to reproduce that end product, and there's transparency, which is really important, one, in open data in the government, and justifying decisions and that sort of thing. So I think the same can be said for creating infrastructure and servers and applications. We want to know what those middle steps are. We don't want that to be a black box. So one of the methods we use is using InfraCode. InfraCode is infrastructure as code, for those who don't know. So when we create our infrastructure, we have a lot of configuration files, which means that we're able to reuse those and redeploy them. These are all stored in a repository, such as GitHub or Bitbucket, and they're quite modular. We've identified common patterns and themes across the agency as well that people can then customise. They undergo code reviews, and automated testing is very important within these infrastructure as well. We build that in as well, and making sure that we can do continuous deployment. So our general pipeline, now this is just a basic general pipeline that we use. So we have our source code or configuration files in a repository such as Bitbucket. We use Packer to create our Amazon Machine images, and then we use Terraform to create our infrastructure using that AMI. And I say AMI for Amazon Machine Image, which is then deployed on AWS. And we use Bitbucket pipelines to do those deployments. Now, the applications themselves could be Python or Java applications, and where they're deployed depends on the application. I'll come back to that later. So, building our AMIs, our Amazon Machine Images, we use Packer. We have common server patterns that we've come across the agency. Things like Apache, so our web server is, the simple web server one there is Apache. We also have Tomcat, Shibboleth for identity provider. And so we can use those and deploy those across the agency. They also have a lot of security features baked into them as well already. So when one of the science divisions, one of the developers or MDTs picks one of those up, they know that it has a lot of the features that they'll need to use in there. This is an example of one of the files that we use in our Packer build. You can see we use our AWS keys, which are environment variables in our Bitbucket pipeline. We specify all the different server information that we need, and then we can deploy various configuration files onto the server and install scripts. Coming to Terraform. So Terraform is our main configuration files that we use to deploy infrastructure on AWS. It's very modular. It is platform agnostic, so it's not just tied to AWS, but we currently just use it for AWS. And we have a lot of example architectures here as well. So a web server with an RDS, a relational database, and also ones with EFS, which is the Elastic File System for AWS. And these are actually have been put through our security team for vetting and our infrastructure architect as well. So taking their comments in to make them more robust, better. The security, again, is baked in. Automated testing is also baked in. And they're actually open source and available at this URL, which will be there at the end. And you'll see it on the slides later. So this is an example of part of a Terraform build configuration file. We use the different modules. We can import variables from our variable file or from build time with the variables coming in. We can get output information and IDs from other modules that are being run as well. And we do some other stuff in Terraform as well to make things easier for us. So so in the top part, you can see that I've got image ID for my image ID, which doesn't tell the system anything at all. But on the bottom, we have a little bash script that we use to find out what the image ID is. And that's based on the tagging that we use in our Packer build. So we tell it to give it several tags and then use those tags to reinsert an image ID into Terraform. So we have this beautiful Terraform script and this beautiful Packer script, and we join them together by a really ugly bash script. But it works. And what this really does is reduce the manipulation, the manual manipulation, human error adding into this. So when we run our Packers, we don't have to worry about going into the Terraform files and putting in our AMI ID. This does it for us, so it's just another click. Terraform allows state locking. So this means that rather than one person being able to run all the configuration files being on one person's computer, the whole team can use it on multiple computers as long as they have the state file. So only one at a time, but they have to have access to the state file. So the infrastructure doesn't get all messed up by multiple people doing things at the same time. If you don't know, Terraform state files require an S3 bucket to be identified, as well as a DynamoDB table, which is all listed in there. So we like having one infracode to rule them all. That is, that all the stacks that we create, dev, test, and prod, or blue-green, is created from only one set of infracode files. We tell it what environment we want on our Bitbucket pipeline. But we also need to use those variables within the code itself. And usually we can just say environment, but things like DNS, we need to use a lookup table to put in the different variables that we want. Terraform has a few quirks. It's not a scripting language, so it doesn't have if statements or for loops. So for our RDS, we don't really care about creating snapshots on delete for dev and test stacks, only for the production stack. So when we delete, we want it not to create a snapshot. So how do we do that? Well, first of all, look at the environment, work out whether it starts with P, and if it does, replace it with a 1, which is false. So it's not the most elegant solution, but that's how we're using it. So coming to deploying the application. How we do that, it depends. It depends on whether the application is fairly static or changing regularly. Sometimes we'll change the application within an AMI, so right at the start in the Packer image itself. Other times we'll use things like Amazon Code Deploy or Jenkins or Ansible to deploy the application after the infrastructure is built. Now, automated testing is very important in this, not only on the server, but in the Terraform as well, in the infrastructure. So we use AWS Spec or GOS. We have some interesting quirks with the testing for AWS Spec, where it had a bit of trouble if there was more than one instance with the same tags. So if one instance went down, was terminated, it stays in the console for a little while. You can still see it. So if you just search on tags, it would still come up, and then the test would fail. So we had to make sure that it knew that it was running and that the test was working. Now, Bitbucket pipelines. All this is done using Bitbucket pipelines to make it easy to deploy everything. So you see, we tell it which environment variable we use. We initialize the backend for Terraform. We build the infrastructure using Terraform Apply. And then we run the tests as well. And this is one of our example architectures, which is why there's a destroy on the end, because we don't need to keep it running. Once people start using it, they take that part off. Monitoring and logging, always important. We use various bits and pieces, a lot of AWS stuff like CloudTrail and CloudWatch. We use Grafana to build dashboards to keep a track of various logging bits and pieces that we want. This is one of our examples of our data sets that are downloaded and the rate of downloads on those, as well as the website requests. We actually could see that one of these accounts actually was in something else that we use, the S3 stat, which was monitoring the S3 bucket. We could see that there was a big spike on, I think it was 30th of July or 15th for our downloads, and that happened to coincide with GeoHack, which is the Canberra event to access data in a hack event. So that was pretty cool. You can see that in the data. Now, one of the biggest concerns in the agency when uptaking cloud was security. People are quite adverse to using cloud very initially because of their security concerns. And so it's always important to address these, but also to build in the security in a lot of the bits and pieces of what we do. So in our AMIs, security is baked in. I mentioned that before, as well as the infrastructure. It's well looked at, it's well covered, and our security team covers that off as well. We also use central account access with AWS organizations, and that enables us also to be able to incorporate logging features across all the accounts in the agency. The second thing that is most worrisome to people when they don't know much about cloud is the cost. They think cloud is going to cost a lot of money, costs are going to blow out, you're not aware of what the cost will be. We are using Cloudability to monitor our costs, and that gives us an indication, and daily emails, which you can turn off if you want to, if you're not interested in the daily emails, for the various costs for the different bits and pieces that you're using and the various accounts. This actually worked out really well for us. We had one of the account owners, but not the developer, come to us and say, I've just found out that for the last 3 days, my bill has gone up from $20 a day to $450. My developer's away. I only had one developer. He was in Thailand. What the hell's going on? So we had a look into it. We got approval to use access to his root account on this account. And looking at Cloudability, we could see that they were actually in beta testing, and one of the people that was beta testing for them was using, I think it was 32 XLs, which was for 24 hours a day to run their code. They'd usually run on the NCI, so the supercomputer, just to give it a good run. So he just chose the biggest one he could. And he was asked kindly to stop, but that was the reason why the cost went up so greatly. If we weren't using Cloudability by the end of that month, because that was right in the first 3 days of that month, we would have got a bit of a bill shock. And so it paid for itself very quickly. And management really liked Cloudability and seeing the dashboards and the numbers come up and keeping track of those. And we can specify different views so a manager can just look at their section that they're responsible for as well. Lambda scripts to shut down the dev and test servers overnight on weekends. That actually wasn't us. That was one of the other MDTs who were really cool. And they're actually in the crowd up there. So I can say that they're really cool. They created these scripts to shut down the dev and test servers overnight so they're not incurring those costs for 24 hours. This was another cost-saving measure. Also using reserved instances for EC2, so the servers and the databases, which reduces costs by almost 50% when you prepay them, maybe 40%. And this just allowed a lot of different ways that we can cost save across the agency. So I'm going to run through a quick example of something that we use. I mentioned Provenance back at the start. That was my previous job, implementing the Provenance server across the agency. So I was working mainly on the code and the business analysis type stuff of that part of the project. And then I moved to doing the infrastructure as well and deploying that application. The Provenance server is an interesting one because it uses a graph database rather than a relational one. So AWS didn't have a good solution for the type of graph database that we needed to use. So we created the first Packer image using Apache and the Fuseki Jena database by itself. And that reason for that was because other applications in the agency also needed to be able to use a graph database like that. So that little pattern was reusable. The second Packer used that AMI and then created installed the Provenance application, which is called PROMS, which stands for Provenance Management System. And then that AMI was fed into the Terraform script, which created their infrastructure. Now, of course, as we're not using an RDS, this is one of the times we're using an EFS, so the Elastic File System, which is mountable on the servers themselves. And so that Fuseki Jena database endpoint, the data itself, was mounted onto that EFS. So if the EC2 went down or cycled, we still had our database, along with all the snapshots, of course. So from beginning to end, if I was to do this process, it would take about 15 minutes. If I'm just changing the provenance application, then that comes down to about 3 minutes. So very quick deployment times on this server. It was really cool. So all the good things. So there's a lot of good things that happened with our move towards AWS and using the cloud to deploy our infrastructure and applications. We found a lot of common themes and patterns, and it meant that a lot of our infrastructure was now in InfraCode and in source control. We saw the same issues across the agency and in different areas, which meant we could centralise common themes which could then be customised to their particular area. But one of the really cool things was that we're upskilling people in the science divisions, the developers and the teams in their technical knowledge, especially with the science. That's really important as well. But while that in-depth technical knowledge was really cool, there's also this general upskilling of knowledge on cloud and acceptance of cloud and security and the cost and what that means and what improvements and benefits that can mean to the agency. There's the starting of breaking down of silos and collaborations across teams across teams. It's really cool to be able to work with other developers who are doing cool stuff a lot across the agency. And I still love my science, so being able to work with different teams who are doing different science applications or different development is really cool for me because I get to still do their sciencey stuff as well. From afar, but still, I like it. And there's a lot of code reuse, which always saves time. Well, one of the best things that has come out of all this is the empowerment. Teams control things themselves now. They don't have to wait for hours or days or months, in some cases, to get their changes through the internal infrastructure team. There's self-service through automation. We have one team that's was always relying on the infrastructure team to be able to do their deployments. With all the Bitbucket pipelines, they're much more empowered. They can do their own thing. And you can see that they're feeling valued, that they're excited about being able to control how they do things and what they do and getting their products out the door. There's upskilling that I mentioned before, feeling motivated, a sense of ownership, and trying out new ideas. It's easy to try new things, and if they fail, you learn from them and keep going and try other things. It's very empowering for the developers and the scientists as well. And that's it. Thank you very much.